I'm going to blog today about lesson 4 in module 2. I think you're going to find this a nice transition from what we've been doing all week. So let's take a look at, we have a little do now activity first. As soon as I can find my mouse, we'll move to it. There we go. All right, so for our opening exercise, go ahead and write 3 equivalent fractions for each fraction below. So we have 2/3 and we have 10/12. Take a minute now and come up with some equivalent fractions. All right. So somebody give me an example of the equivalent fraction for 2/3. 4 6. Do we have another one?
6 times.
You scaled them up both up by multiplying by 3.
20/24.
Not 20/24, because if you scaled that by multiplying by 10, and we want to scale that by 10, so what would our denominator be?
I was saying for 13.
Oh no, I'm still on this one. Okay, because we wanted at least 3.
So
Can we come up with another one?
8/12.
Sure. Whoops. 8/12 times 4 times 4. Can we scale that one down? No, can't scale that one down at all. All right, what about 10/12? Do we have any equivalent fractions for that?
20/24.
Sure. 20/24. You scaled them both up by multiplying by 2.
100/120.
Yup, absolutely. What else?
5/6.
Yeah, this one we can scale down by dividing them both by 2. And one more? And one more.
30/36.
Sure. Okay, so a little review from earlier in the year, and we could be here all day coming up with equivalent fractions, okay?
What this one? Would it be 20/30?
It would, I'm sorry. I erased it and then I rewrote it wrong. I apologize.
So, question about the equivalent fractions. So, equivalent fractions is basically the fraction being scaled up or scaled down.
It's
correct?
exactly what it is. Whatever you increase the numerator by, you have to increase the denominator by, okay? All right. Let's get back to what we worked on yesterday, dividing fractions by fractions. Molly purchased 1 3/8 cups of strawberries. This can also be represented as 11/8. So 1 3/8 equals 11/8. Do you remember that? 8 times 1 is 8, plus 3 is 11. Remember that from elementary school? So 11/8. So she has 11/8. She eats 2/8 cups in a serving. So how many servings did she purchase, or how many servings can she make? So what are they asking us to do? Ooh, they're asking us to slam that door shut. What are they asking us to do? We have 11/8. This is what I like to do when I cook, and then I like to scoop it out into smaller individual cups, and then freeze them that way so that I have them. So what do we have here? Michael, what are we trying to do? What are they asking us?
To subtract.
No. Not subtract. I have 11/8. I want 2/8 here, 2/8 here, 2/8 here. I'm going to take my 11/8 and separate it into 2/8 servings. What am I doing? What am I dividing? 11/8 divided by 2/8. I'm just going to make up numbers all day today. So pay attention. Make sure I'm doing it correctly. All right, so how are we going to do this? Exactly like we did it yesterday. Let's see, 11/8. You can do a number line if you prefer. So here's 8/8, 9, 10, 11. Now I have a tape diagram, or a number line if you prefer, that illustrates 11/8. In my 11/8, how many servings of 2/8 can I make? Here is 2/8, 2/8, 2/8, 2/8, 2/8. I did not finish circling all of my shaded areas. So because I didn't finish circling all my shaded areas, I need another group of 2 to include that last shaded area. So how many whole groups of 2 did I make? 1, 2, 3, 4, 5. I made 5 whole groups, and in my last group of 2, what do I have? A half. So she is able to make 5 1/2 servings. So because 8 was my denominator, I drew my tape diagrams with 8 boxes. I took my whole tape diagram and divided it into 8s because 8 was my denominator. But I needed 11 of them, okay? Now let's take a look. That's what Molly bought. But now Molly's friend, Xavier, he also purchased 11/8 of a cup. He bought the same amount. However, he eats 3/4 cup servings. So how many servings? So how would I write this? What are we looking for here? Right. So he has 11/8, but he's going to divide them into 3/4 cup servings. He likes to eat a little more strawberries at a time. So what's different about this problem than the first one with Molly? Yeah, this one does not have common denominators. Let's look here. On this one, we had 8 and 8. We kept talking yesterday about how nicely this works out because we had common denominators. But now Xavier went and messed that all up. I don't have common denominators. I have an 8 and a 4. It would be so much easier if they had common denominators. Wouldn't it be so much easier? Wait a minute, why do you all have your hands up? Do you have an idea? What's your idea? What should I do? Everybody? Oh, I should change one of them so I have common denominators. You're smart. So which fraction should I change to equivalent? Yeah? which one should I change to equivalent fraction? Tina?
3/4.
So 3/4 is equivalent to how many eighths? 3/4 is equivalent to how many eighths? What can I scale that up to? 6/8. Now is that easier to divide? Go for it. Either give me a tape diagram or a number line. Because my denominator is 8, I'm dividing my tape diagram into 8. So I have my boxes of 8/8. Now I need 11 of them. So here's 8/8, 9, 10, 11/8. So now my picture shows 11/8. And I'm going to take my 11/8 and group them into 6/8. So that's 6/8. 1, 2, 3, 4, 5, 6. And that is 6/8. So I have one whole group, and then I have 1, 2, 3, 4, 5 out of 6. So my answer is 1 and 5/6. Okay? Yes, you should. You should always simplify your answer if you can. Okay?
It's 7 boxes.
1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And that's a good idea to always check because you can go a little cross-eyed trying to make these. All right, go ahead. Try number 3. I'm actually going to stop the recording now because I'm going to have you working on these on your own. So if you do not have common denominators, change one of the fractions to an equivalent fraction by scaling up or scaling down so that you have common denominators. draw your model still, and then we'll go over the answers at the end of class. If you're watching the blog, you can put the answers off of the notes to check your answers. Would you like me to do one more as an example? Okay, I'll do one more. If you don't need it, go. If you want another example, I'll do one more example before I stop the blog. So 3/4 and 2/3. What would a good, can I make the 3 into a 4? No. Make the 4 into a 3? No. But what number can I use?
12.
12. Let's try 12. I like 12. That's a nice number. So what's an equivalent fraction for 3/4 that has a denominator of 12? I like it easier writing them this way. So times 3 would be 9. So that would be 9/12. 2/3 is how many 12s? Times 4 times 4, 8. So now my new equation, which has the same value, is 9/8 divided by, 9/12 divided by 8/12. So, want me to draw a number line, or do you want me to do the tape? I'll do a number line this time. All right, so I need 9/12. So I'm actually going to stop my number line here. I want groups of 8/12. So here are 8/12. So I have one whole group, and then I have 1/8 left over. Because if I made another group of 8, I see that one of them would still be included. If I made another group of 8, I don't even have to keep my number line. I know I'm going to make a group of 8. And I know that there's one here in my next group of 8 because of where this gets cut off. So it's 1 and 1/8.
I understand. Okay, so it's one group of 8.
Mm-hmm.
And then what's the other group of 8?
This is your group of 8, but because we cut this group of 8 off here, there's only 1/8 here. There's only one spot out of the 8 that's included. So it's 1/8.
Okay.
So your answer is 1 and 1/8.